Okay, good day everyone. So we will be um, discussing today about mechanics in marine engineering. So our course outcome one is analyze the importance of the principles of mechanics in marine engineering. So we have here the learning outcome 1.1, solve problems involving statics applicable to marine engineering. So these are the topics. Okay, so let's start. First, statics in marine engineering is a branch of mechanics. Static is a branch of the mechanics that deals with bodies at rest and forces in equilibrium. So in marine engineering, statics is applied to analyze the forces acting on ships, like this one on the picture below. So we have sideward sway, the waves, the wind, the yawing of the ship, the current, the thrusters, the propulsion, main propeller and rudder, and the surge of the ship. So those are the forces acting on ships, offshore platforms, and other marine. Okay, so statics in marine engineering. So there are different examples of statics, like this static stresses in our ship. So we have here a hugging. So there are forces that on below that compresses the underside of the ship and force upward. So there is tension on the upper part of the ship. So that is hugging. Next we have sagging. So it's like a banana sagging. So sagging. So there is tension on the bottom part while compression on the upper part of the ship. Then the water pressure outside the ship. So there is also pressure outside. So those are part of the stresses on our ship. And then during dry dock, there are um, the ship sides are no longer supported by water pressure. So the only thing holding the ship are keel blocks, this one, bilge blocks, and side shores. So the ship is uh, looks like it's gonna expand, or so the result is that the sides of the ship tend to bulge outwards and the bottom tends to sag. So to counteract dry docking stress, the entire bottom of ship is strengthened. Okay, so introduction to mechanics. So mechanics is a branch of physics that deals with the study of forces, motion, the behavior of materials. So in marine engineering, mechanics is fundamental to understanding how ships, submarines, offshore platforms, and other marine structures function in response to the forces they encounter at sea. So it plays a critical role in the design, construction, operation, and maintenance of vessels and offshore systems. So as you can see, there is someone who is performing maintenance and for the operation for inside ships. So they are what we call the marine engineers. Okay, so marine engineering relies heavily on both statics, or which is the study of objects at rest or in equilibrium, and dynamics, the study of objects in motion, to ensure the safety, efficiency, and performance of marine systems. Okay, so key concepts in mechanics applied to marine engineering. First, number one, forces and moments. So forces are vectors that cause objects to move or deform. So sa engine, meron tayong forces, which is the piston. The forces in the piston, that is piston connecting rod, or piston rod, crosshead connecting rod, and that is the one that helps rotate this crankshaft. So those are the forces. And then those linear forces or reciprocating forces will be converted to rotational forces, like this one and the crankshaft. So this is the crankshaft. We have here the gears and the propeller shaft and the propeller. Okay, so the force that cause rotation for these parts is the moment or the torque. Okay, next, static in marine engineering. Static deals with forces acting on stationary objects or systems in equilibrium. And in the context of marine engines, this can include analyzing forces on engine components, engine mounts, vibration isolation, and the distribution of stresses across structural components. So, syempre sa barko, pag nakita mo siya, so mawawala talaga yung stress mo. Diba? Lalo na pag naging ganito na siya. O, diba? Ang ganda-ganda na. So, sa barko, wala tayong magugupit. So, pag umaba na yung buhok, gumaganda din pala tayo, no? So, statics in marine engineering, static deals with forces acting on stationary objects. So, ito. Okay, so let's go with an example of static forces. So, as you can see, meron tayong babae dyan. So, yung babae is hindi kasama yan. So, dito tayo titingin sa piston. So, this is the piston of an engine. Okay, please huwag nyo tingnan itong babae. Ba't kayo nandiyan nakafocus? Okay, so dito tayo ha, marine engineers. Okay, so, the piston, pag binabaklas yung piston natin, yan, this is the piston. So, tingnan natin gano'ng kalaki yung piston natin. At tapos, yung piston is merong mahabang piston rod yan. So, ganun ka tangkad. Ganun ka tangkad yan. Mga 3 tao ata na foreigner. Pag Pinoy, mga 4 na Pinoy yan. Ha? Okay, so, itong piston na ito, pag inaangat yan, ginagamitan natin yan itong engine room crane. Ito, this is an example of a crane. So, yan yung umaangat dyan. So, hindi pwedeng iangat yan ng tao lamang kasi ang bigat-bigat niyan. And then, pag naka-stationary na yan dyan, hindi yan mahulog. Dapat kayang iangat ng crane yan. And then, on that state, naka-static, may static energy or force na nangyayari dyan. Okay, number 3, dynamics in marine engineering. So, dynamics involve the study of forces and their effects on motion. So, in marine engineering, dynamics plays a role in ship propulsion, seakeeping, and vibration analysis. So, sa atin, for engineers, medyo concerned tayo sa ship propulsion and vibration analysis. Also pala seakeeping. So, with dynamics, so, yung mga forces na yan is kailangan nating mabababa yung vibration. So, dapat magkaroon ng balancing of forces. Okay? So, yan. Next key concept in mechanics is the fluid mechanics and hydrodynamics. So, fluid mechanics deals with the behavior of fluids and their interaction with solid bodies. So sa barko, parang propeller yan. So, di ba? So, yung interaction ng dagat at ng propeller para mapatakbo natin yung barko. And their interaction. So, hydrodynamics is the buff subfield of fluid mechanics. Focus on the behavior of water around ships and marine structures. Okay, number 5. So, another key concept is the ship stability and structural integrity. So, the stability of a ship is a key focus of marine mechanics, as a vessel must be able to resist tilting or capsizing under various conditions. So, the metacenter and the center of gravity are used to analyze stability. So, marine engineers study shear forces, bending moments, and stress distributions to ensure that the ship's structure remains intact under external forces such as waves or collision. So, makita natin yung dagat is paangat dyan. So, there is a force acting on to the ship. And dito naman is walang dagat or pababa yung dagat. So, merong bigat na ng barko. So, pag yung mga pwersang yan ay hindi mo mabalanse, maaaring mag-capsize yung barko, mabali, or masira, or lumubog. Okay, next key concept in mechanics, we have the hydrostatics and buoyancy. So, hydrostatic is a branch of fluid mechanics that deals with fluids at rest. So, hydrostatics and engine room play a critical role in ensuring the safe and efficient operation of the ship. So, as you can see the picture, ito yung nagbabunkering sila ng fuel. So, that fuel will be used to start our ship. Okay. So, hydrostatics. So, since hydrostatics and buoyancy, ano yung mga example ng hydrostatics and buoyancy? So, we have the ballast water system. So, this, the water inside these tanks is the one that will maintain the stability of our ship. So, ballast water is transferred between tanks to maintain the stability and trim of the vessel. So, hydrostatic principles, pressure difference caused by water levels and densities are used to pump and redistribute ballast water. Okay, number 2, cooling water system. So, sa barko, meron tayong cooling water system for our engine. Circulates water to cool the engine and auxiliary equipment. So, in hydrostatic principles, proper head pressure is maintained in the system to ensure efficient cooling. So, kailangan tama yung pressure mo para ma-maintain natin yung cooling ng ating engine. Next, for the fuel oil system, fuel oil is transferred and supplied under pressure to engines and generators. So, the height of the fuel oil storage tank relative to the engine affects the gravity head, influencing flow rates. But on ship, meron tayong nilalagay ng mga booster pumps to increase the pressure to maintain the pressure of our fuel system. So as you can see in the picture below, we have dual fuel engines. So they are using gas fuel and liquid fuel in starting or in running the engine. Okay, next, let's go with lubricating oil system. So circulates lubricating oil under pressure to reduce friction in moving engine parts. So the hydrostatic principles, oil reservoirs rely on hydrostatic pressure to maintain a consistent supply to pumps and engines. Okay, next, bilge and ballast pumps. So remove water from bilge space and transfer ballast water. So hydrostatic principles, pumping systems use pressure from one area to transfer the liquid from one area to another. 6. For hydrostatics in engine room. Examples, so we have hydraulic systems. Operate various machinery like cranes, steering gears, and stabilizers. So yung crane natin, hydraulic yung nagpapa-operate niyan para makaangat siya ng or ma-transfer niya yung something from one place to another. Pero dito, parang nagkamali na ata tayo ng mechanics dito. Unbalance, naging unbalance na. So nasira, nahulog yung crane. Yun. So hydrostatic principles, hydraulic fluid pressures are governed by Pascal's law to transmit power efficiently. Okay, next, hydraulic system. Another example of hydraulic system, we have here a steering gear. So this steering gear is using hydraulic system. So ito, hydraulic pump natin with motor. So para ma-move natin yung rudder left and right. Ito yung connection niya sa ilalim. So medyo hindi yan konektado. Nilagay ko lang. And then other example for hydraulic systems in hydrostatics is the use of the gyro fin. Ito. So ito ay gyro fin stabilizer para ma-stabilize natin yung barko, hindi siya masyadong malakas yung pag-movements niya. So nilagay yan sa gilid ng barko, especially pag yung barko mo is on cruise ships. Okay, another example for hydrostatics engine room, we have the firefighting systems. So it deliver water or foam to extinguish fires in emergencies. So ensuring adequate pressure in system to deliver water to required location. So pag walang pressure or sila yung pump mo, so walang tayong mapapatay na apoy. So here an example, we have here a firefighting nozzle. We have here a water mist. So mist para mas pino ang spray, mas madaling makapagpatay ng barko, and then mas less yung tubig na mapupunta sa barko, so hindi masira yung stability mo. Sa baba naman is an example of a sprinkler. So medyo malakas yung spray ng tubig dyan, so hindi maganda sa barko kasi nagiging nagkakasira siya ng stability ng barko. Okay, next we have the sea chest operation. Intake of seawater for cooling, ballast, or other operations ng barko. So dumadaan yan lahat ng sea chest. Okay, so maintaining sufficient depth of submergence to avoid cavitation and ensure steady intake. So dapat itong ating sea chest na yan is nakalubog yan dapat sa ilalim ng dagat. Pag hindi yan nakalubog, so walang masasaction, so wala din. Useless din. Okay, next we'll go. Okay, so diretso na pala to. Basic concept in statics. So this is our next topic, basic concept in statics. Okay, so number 1, foundation of engines and equipment. So yung engine na to is 1, 2, 3, 4 na palapag na makina. Ganun siya kalaki. So ang nag-hold sa kanya is para di siya matanggal or mag-move sa loob ng barko is this holding down bolts. So maraming mga holding down bolts yung ilalagay mo para ma-maintain mo ang kanyang static forces or equilibrium of forces and movements. So the engine is mounted on a rigid foundation to ensure it remains stationary during operation. Bolts and supports are designed to counteract the forces and moments produced by the engine's vibration and torque. Okay, next, for crane and lifting gear, the concept is force, equilibrium, and center of gravity. So example, so overhead cranes are used to lift heavy components such as cylinder heads, like this one. And static analysis ensures the crane can handle the weight without tipping or structural failure. So na-experience namin yan, tanggal yung nasira sa taas, nahulog yung fuel pump. So butin lang, walang tao. Okay? So application, determining tension in lifting cables and reactions at support points. Okay, another basic concept in statics is the ladders and platforms. So ito yung mga ladders natin. Ito yung mga platform dyan. So dyan tayo magtatrabaho, dyan tayo akyat baba sa engine room. So medyo galing dito, dito yung control room mo, bababa ka dyan. Dalawang stairs yan. And then punta ka dito, ikot ka dyan, baba ka naman dito. Punta ka sa baba, bababa ka naman dun. So medyo malaki talaga yung engine room na ito. So, concept, stability, and distribution of force. So, example, platforms and ladders in the engine room are analyzed to support the weight of crew and tools. So, applications, calculating stresses and ensuring sufficient safety margins. So, yan, syempre, before ginawa yung barko, kinompute na yan ng mga ship, anong tawag doon? Ship makers. So, dapat, syempre, yung platform and ladder na yan is matibay, kayang mag-support ng tao, pati yung tools at mga equipments pag nagme-maintenance ka. Next, another basic concept of statics is the pipe and valve support. So, ito yung mga valves mga pipes natin. Yung pipes na yan is meron yang dito, nakakonekta sa kanya, para hindi siya tatakbo-takbo pag gumagalaw na yung barko. So, mayroon siyang parang nag-hold sa kanya. Okay? So, the pipes carrying liquid exert loads on their supports due to the weight of the liquid and the pipe. So, analyzing the forces on support brackets to prevent bending or failure. So, yung may mga support bracket dyan. Lalo tong malalaking mga tubo, may mga support brackets yan to prevent it from moving or masira siya pag may tumatakbo na. Okay, next, hydraulic press or jack. So, force transmission through static equilibrium. So, pag may pwersa ka ditong ilalagay, kahit maliit lang, tapos pupunta siya dyan, so angat itong load. Diba? Di ba ito gumagalaw? Okay. So, hydraulic jack used to lift heavy machinery operates on Pascal's principle, balancing forces within the system. So, application, designing the jack to withstand forces without deformation or failure. So, kung yung jack mo, meron niya nakalagay kung gaano lang kalaking load ang pwede niyang iangat. So, focus or wag mo gamitin sa mas mabibigat pa. Okay? So, always read the manual. Okay, next. Shaft and bearing support. So, this is our engine. Dadaan siya ng itong truss block. And then dadaan pa siya yung shaft niya. Dadaan pa ng another intermediate bearing. And then, bago pumunta sa stern tube and then dun sa labas sa kanyang propeller. Okay. So, shaft and bearing support, load and moment balance. So, example, the engine's crankshaft, ito yung crankshaft nandito sa loob ng makina, and other rotating equipment rest on bearings that support axial and radial load. So, ito yung ating intermediate bearing at ang thrust bearing. So, yan, nagsusupport yan para support axial and radial loads. So, application, analyzing forces at the bearings to ensure they can handle operational stresses. So, yung mga bearings na yan is kinalculate yan na syempre kaya nila yung mga stresses na ibabato sa kanila. Number 7, load balancing on deck. So, center of gravity and distributed load. So, example, heavy machinery in the engine room is positioned to maintain the vessel stability. So, for example, yung main engine, ilalagay mo siya sa gitna para hindi na mahirapan yung barko sa pag-stabilize sa kanya, lalo na pag isa lang yung main engine mo. Diba? Pag ilagay mo yan sa gilid, so hindi pa tumatakbo yung barko, nakatagilid na. Kasi ang bigat-bigat ng engine na yan. Pati itong mga generator and other machineries is binabalanse din nila yung pagkalagay sa engine room. Okay, so heavy machinery in the engine is positioned to maintain the vessel stability. So, distributing the weight to prevent excess stress on structural beams. Okay. So, next topic. Bilis pa rin ito. We have force system and components. So, force system. Types of forces. We have the point loads and distributed loads. So, concentrated forces or point load. This one. So, concentrated forces exert at point or location. So, dyan lang nakafocus yung kanyang load. While distributed forces, ito yung mga force applied along a length or over an area. So, yan lahat na didistribute yung load sa lahat ng parte dyan. from A to C. So those are the types of forces. Application. So a distributed load on the beam exists due to the weight of the lumber. So this is an example. So dito ang weight ng lumber is distributed on all parts of this beam. Yun. So another application, the sandbags on the beam create a distributed load. So yan, pantayan. Mas konti lang dito yung load dito banda, pero sila lahat sa buong beam from A to B is nagkakaroon siya ng load sa lahat ng parte na yan. Okay, force systems and components. Okay, force systems. So force representations, vector representation of forces, magnitude, direction, and point of application. So this is an example of an engine. So this is a 4-stroke engine cycle. So yung una, yung pagbaba ng piston, mayroong arrow dyan. Ito yung piston yung nasa gitna. Pagbaba ng piston, bubukas itong valve na ito. Papasok itong blue. So yung blue na yan is fresh air. Hindi yan fuel. Mali yan. So fresh air, papasok, bababa yung piston pababa. So that is the intake stroke. So intake of air. Pagkababa ng piston, akyat siya ulit kasi paikot lang to yung crankshaft niya. Paikot lang yan. So angat ulit yung piston. Pag angat niya, magsasarado itong intake valve. So magsisimula na tayo. Pag angat, magkukompress yung hangin na nasa loob niya. That is the compression stroke. And then pag nasa taas na siya, magsispray itong ating fuel. So dito parang combination ata yung fuel and air dito. Diba? Kasi dito spark plug. So gasoline engine pala to. Pero same lang naman yung 4-stroke engine cycle. So pag aakyat ng piston, compress na yung air. And then air and fuel compress na, and then magbibigay ng spark yung spark plug, and then sasabog yung ating fuel and air mixture. Pag sabog niya, itutulak niya ulit yung piston pababa. This is downward force. So this is the power stroke during combustion. And then aakyat ulit yung piston para ilabas niya yung mga exhaust mo, or yung mga natira sa combustion, yung mga exhausts mo. So itutulak naman ng piston pataas kasi paangat na yung arrow. And then lalabas niya dito sa exhaust side ng ating valve. So this is the exhaust valve. Ito naman yung intake valve. So lalabas sa exhaust valve. And pagkatapos niyan, bababa na naman yung piston, babalik dito sa intake stroke. So ganun yung sistema natin sa 4-stroke engine. So makikita natin, yung piston natin dyan is meron tayong force na nagtutulak sa piston pababa. This during combustion, that is the gas force. And then merong pwersa na itutulak naman yung piston patagilid. So that is the normal force. Papunta dito sa gilid na wall, sa liner. And then meron din pwersa na bababa dito sa connecting rod. And then yung pwersa ka sa connecting rod is ma-distribute sa crank na force at dito sa tangential force. So those are the forces na meron sa loob ng ating engine. So meron pang mga frictional forces dyan, kahit ano pang mga forces na nandyan. Sliding friction force at iba pa, di ba? Sa loob ng engine habang umiikot yan, habang yung piston is bumababa at tumataas at bumabagsak. Okay, those are forces. Force classification of force system with the coplanar and non-coplanar forces, and the concurrent, parallel, and non-concurrent force systems. So resultant forces, methods to find the resultant of multiple forces acting on a structure. So total force mo. And the force resolution components, breaking force into horizontal and vertical components for easier analysis. So ito yung nangyayari. Binibreak natin siya for easier analysis. Okay. So that is that's all for force system and components. Next, we'll go to okay, so yun lang. So this is an example. So ang tawag naman dito is gas force. Okay, so in this gas force, we have here forces all over. We have gas force that pushes the piston down. We have force, the sideward force sa piston papunta sa kanya liner. We have the normal force. So yung gas force na yan is po-project natin dito, pababa kasi straight line yan. And then magkakaroon ng pwersa papunta sa ating F-con. And with the use of that, so meron tayong Pythagorean theorem, meron tayong Sukatoa, Pythagorean theorem din, and we have sine law. So we will have to use this one in solving the gas force, the F-con, connecting rod force. We have the normal force. We have the crank pin force or crank web force, and we have the tangential force also. So also we can solve for the torque, the mean piston speed, and the power produced of the engine. So based on this um, um, diagram. Okay, so this video will be that's all with our video today. So the solving for gas force will be on another video na lang if ever may time pa tayo. Okay, so I hope you have learned something about mechanics in marine engineering and also statics. Sa na under siya, subtopic siya ng mechanics. Okay, so I hope you learned something and see you on the next video. Okay, bye!